Here we are discussing question number 12 from miscellaneous exercise of the chapter Straight Lines. Question has been taken from NCERT book of class 11. Here question is, show that the equation of the line passing through the origin and making an angle of theta with the line y is equal to mx plus c is y by x is equal to m plus minus tan theta upon 1 minus plus m tan theta. Very important question. Let's see the solution here. We know equation of the line passing through the origin and making an angle of theta with the line y is equal to mx plus c. We will use slope point form here. So equation of a line is slope point form is y minus y1 is equal to m x minus x1. Here this line is passing through origin. Here line is passing through the origin. And we know that origin has coordinates 0, 0. Therefore, this equation will be satisfied by y1 is equal to 0 and x1 is equal to 0. This may be supposed as coordinates x1, y1. So in place of x1, y1, we can put here 0, 0. Therefore, y minus 0 is equal to m x minus 0, or y is equal to mx. Suppose this is equation number 1. Now we need to find out the value of m, and putting the value of m here, we will get this result. And how to get value of m? For that, this is given that this line 1 makes an angle of theta with the line y is equal to mx plus c. Okay, so we'll find the slope of this line. Okay, let slope of this line be m1. So in place of m, we can put m1. And here slope of this given line, here given line is y is equal to mx plus c. So slope of this line is equal to m. Now the required line and this line, between these two lines angle is theta. So we can use a formula, tan of theta is equal to modulus of m1 minus m, where m1 is slope of this required line. We are supposing m1 here, and m is the slope of this given line, upon 1 plus m1 into m2. Since modulus is here, so this may be positive or negative. Okay, in both the cases we will get the result. So we can write here m1 minus m upon 1 plus m1 into m2 is equal to plus tan theta, and m1 minus m upon 1 plus m1 m2 is equal to minus tan theta. Okay, so we will discuss here two cases, and in both the cases we have to find out the value of m1, and we will put this value m1 in place of m here in equation number 1. We will get the result. So when m1 minus, this is m1 minus m. When m1 minus m upon 1 plus m into m1 is equal to tan theta, This implies by cross multiplication m1 minus m is equal to 1 into tan theta, that is tan theta, and plus minus m1 tan theta plus m1 tan theta. We have to find out value of m1 here, so we'll transpose this term to left side and this m to right side. So, or when we will transpose this term to left side, we can take m1 common here. Okay, so m1 1 minus m tan theta is equal to 1 minus m tan theta is equal to m plus tan theta is equal to m plus tan theta, or we are getting m1 is equal to m plus tan theta upon 1 minus m tan theta, 1 minus m tan theta. Here we are getting value of m1. Now we'll take this case when m1 minus m by 1 plus m1, not m2, m1m is equal to minus tan theta. By cross multiplication we'll get m1 minus m is equal to minus tan theta minus m1 m tan theta minus m1 m tan theta, correct? Or we'll transpose this term to left side and this term to right side. When we'll transpose this term to left side, we can take m1 common. So m1 here, 1 from here and from here, plus m tan theta plus m tan theta is equal to, in right hand side, m minus tan theta, m minus tan theta, or m1 is equal to m minus tan theta upon 1 plus m tan theta, 1 plus m tan theta. So when we see this value of m1 and we are getting this value of m1 here, by combining these two results, in numerator here is plus as well as minus, so we can write plus minus, and denominator this is minus and plus, so we can write minus plus. So therefore by combining these two results, m1 is equal to m plus minus tan theta upon 1 minus plus tan theta. Now we'll put this value of m1 in equation number 1 in place of m1. Then we'll get the result. Okay. So now putting m is equal to m1 is equal to this corresponding value of m1 is equal to m plus minus tan theta upon 1 minus plus tan theta in equation number 1, will get y is equal to m plus minus tan theta upon 1 minus plus tan theta into x. Or now transposing this x to left side, we will get this result. Or y by x is equal to m plus minus tan theta upon 1 minus plus tan theta. So we are getting this result here. So it has been proved. This is very interesting and important question. Hope you understood it. Okay, I will suggest you to do some practice yourself, okay, so that we could have a command over this question. Question is not very difficult but little bit lengthy, so you must try to solve yourself. Okay, and share this video with your friends also. And if you are enjoying these videos, getting benefit of it, your likes are most welcome. Wish you all the best.